them equals 1 instead, I would have had to go back to the beginning of the line and change this print to set, and I don't want to do that. So they made it really easy to just go back and add things to lines. So if you could see my fingers, which wouldn't be that exciting, you would notice that I'm using all sorts of Emacs key bindings here. So this whole thing is built on top of a GNU readline library. So there's history, there's previous command, next command, beginning of line, end of line. I assume you guys hopefully by now are getting some hang of using a lot of that stuff at the command line. And if you're using a good editor, you're used to some of those things. So all that stuff is built into GDB. It's all designed to make things nice and fast. Okay, so that was a first example on debugging a program. Let's see, what else do I want to point out? Quick, somebody ask me a question so I know you're awake.
So the meaning of life is 42?
Yeah.
Doesn't sound
Yeah, that's a, yeah, it's a Hitchhiker's Guide to the Galaxy reference.
Yeah.
Or XKCD if you encode it.
Let's see. Okay, so we learned a few commands there. We learned the where command, tell you where you are. List will list the source program. Print will let you find out things. Let's look at another program here. I've got one called, I'm going to quit out of this because I don't care anymore about the meaning of life.
You tried to make it infinity, but it didn't work.
Oh,
Yes.
Divided it by 0.
it's true. The meaning of life is infinite. It's profound somehow. Okay, fine. So I've got this other program I have carefully crafted called memory. So let's run that program. Oh no, I put an error in there. So it's going to run this stuff. I'm going to get, in this machine it's a bad access, couldn't access memory at some location. So I say, where are you? Okay, well, now at this particular point we start to see a stack frame. You know that I'm inside some string cat checking program that I wrote, but it doesn't tell me anything about it. I'm in some inline function, but I'm starting to sort of zero in on where I am. So right now I'm in frame 0, and that isn't going to do me much good. I can go up, if you think about sort of up into the person who called you. Now I'm in frame 1 at some line in my program. I can go up again, and that takes me to frame 2, and I am at a point at which I am inside a function called my copy, a subroutine that I've written, and string cat is apparently dying for some reason I haven't figured out yet. But somewhere inside string cat, which is a concatenation function. Now you'll notice that I don't have a lot of information about string cat. That's one of the library routines. I don't know what went wrong in there. I just know I'm in there. So let's see. I'm at that frame. I wonder what went wrong. Well, I can say print string. Okay, this is buff1. So that looks good. Print buffer. Buffer. That doesn't look. That looks a little bit strange, but okay. How did we get here? Well, I'm going to go up again. I'm going to list my program. I am inside my copy, the thing we were just looking at. I pass the string. This is buff1, which is what we got inside there. And what this rather badly written program is supposed to do is copy this into buff1. Now, I don't see any problem with that. It doesn't like it so much. So what's the problem?
There's no memory allocated in buffer 1.
Yeah, there's no memory allocated for this. Now, I did carefully allocate memory for buffer 2 because I was trying to get extra credit. But I forgot to do that for buffer 1. Now, that's funny because when I asked it what it was, it's not null. It's got a number. It looks got S7s and Fs and stuff. It looks like a pointer address to me. So why do you think I had a problem? Who's had operating system class already? Okay, so why did I have the problem?
Because the memory is uninitialized.
Yeah, it's uninitialized. Now, where were these variables stored? They're on the stack. Okay, this is going to be a little bit much for some of you guys, but which means that they're uninitialized, but they're uninitialized in ways that tends to be kind of annoying. So they've got values that look like they might be pointers or something. They're not 0 because the compiler won't bother to set them to 0. That would just take longer. But they're not working so well. So that's the reason that particular program is having problems. Now, I could, in theory, I think, if I said print, where am I? Frame 3, print buff1, which is indeed none. If I say print buff1 equal memory allocate 100 bytes, hey, look, I can do that. Okay, so now I just allocated memory for this thing. I wonder if the program would survive. Maybe that's the only bug in my entire program. That happens all the time, right? I wonder if I hadn't made that bug, if the program would work. Trying to think. I hadn't scripted this one up. Oh, well, we'll go ahead and do it. I wonder if I hadn't made that mistake before I did this. Okay? I wish I could run the program and stop on line 22. I wish I could run the program on break on line 22. Hey, look, I just said break on line 22 and it said it would. So I'm going to type run. It says you want to start from the beginning because I'm in the middle of it. So I say, yeah, go ahead and start from the beginning. I haven't accomplished that much. So now it says, okay, breakpoint 1. Memory.c line 22. Just before I called this thing that was kind of wonky. I wonder if I hadn't screwed that up. What was that stupid thing I typed? I had something with a malloc in it. I don't remember. I don't want to type it. But I'm a good touch typist, so I'll say Control-R and malloc, and hey, there's the line I had. So, okay, now I have allocated space for that buffer. Now I want to continue. Well, continue is a darn long word. I wonder, let's see, continue. Okay, fine. GDB, written for geeks. All right, as long as the command is unambiguous, it will run it from an unambiguous prefix. Now, they very carefully didn't have another command like chat or something, because that would just annoy you. So with things like step, next, continue, that's why all of the later commands are really long and start with funny letters. So those of us who just want to type C for continue can get it. So I was actually able to modify this program, get it to do what I want, and then verify that, well, modulo it doesn't do anything useful, it would survive if I had the memory to do that. Okay? Cool? All right. What else can we do with this stuff? Where's the dump program? Okay, so we looked at where, we'll tell you where you are, including the stack frames, because that can go down and up. I can list the program. Now, occasionally, list keeps track of which files are involved, but if you have a situation where you have to switch files, you can tell it which file to list. You can look that up. We looked at print. Now, I need to show you something very important. Let's look at Optim 3. Sounds like a great movie. Okay, here's a really profound program. Initializes a couple of variables and passes them to this subroutine, which first I add them together, pass them to the subroutine, add 10, and print out the number. Okay, no big deal. I'm going to compile this and run it, and it says 22. Okay, that's not a problem. Let's say, for example, that I wish I knew what happened to this program if B were an 8 instead. Okay, GDB on Optim 3, optimize with 3. I'll just run it, just make sure the right thing happens. It says 22. I'm going to list the program. I want to stop it at line 25. Break line 25, run it again. So it gets to the point that it's going to call line 25. I can, at this point, I can ask it about the variables. So let's say I want to know what A is. Print A. Oh, man.
Yeah.
Variable optimized away by compiler. Well, that stinks. Okay, I can deal with this. Let's catch it inside the subroutine. All right, break SBR. Run the program again. Oops, that's the printf. Delete breakpoint 1. Run it again. 22. Break subroutine. Says there's already one there. Run. 22. Huh. Okay, let's look at this now. We're getting confused. There is a subroutine called subroutine. darn it, I called it right there, and I set a breakpoint, and it didn't go there. Why?
It's only called the one time.
Nope,
Nope,
because
the compiler
I
takes it
forgot
away.
the cardinal rule in debugging a program, and that's about optimization. So what has happened is that this particular program was optimized with -03, because I wanted it to be really, really, really fast. So it did a couple of things, kind of annoying. You'll notice that it said A had been done away with by the compiler. Variables A and B no longer exist. Why? Well, the compiler said, well, geez, you initialized these to 5 and 7 and you never changed them, and I'm just going to add them together. Why in the world would I bother to store those in memory only to add them together and pass them along? I throw all that stuff away. So it did. So I can't ask it about A and B, they're gone. Furthermore, it looked at SBR, made sort of a value judgment about my ability to code correctly, and said, you know, come on, man. And so it just inlined it and just put it right here. So although the subroutine is still there, it doesn't call it. Because what's in the subroutine is so simple, it's going to roll it into the program. So, what we learned from this is that I'm going to remove opt-in 3. And the rule that made opt-in 3 used -03. That's where the 3 came from. If I had instead remove opt-in 0 and made opt-in 0, which is the same program, compiled differently, opt-in 0, break, SBR, run, hey look, I'm in the subroutine. Or I can, at that point, break 25, run, print A, and my variables are back. Okay? So, what we've learned is, but I still can't find my program. What we've learned is that optimizers rearrange lines, and this is actually really annoying. You'll see that the program doesn't run sequentially anymore. It inlines function calls, like that subroutine that was gone. It will unroll loops. If you've got a loop from 1 to 5 or something, it might just forego the loop and just put 5 to